Hello. So today's notes, we are going to learn about the counting principle. We're going to learn about permutations and combinations. Your heading should look different than mine because I printed mine out before I made the heading look nice. All right, for vocabulary, first of all, what is a permutation? A permutation is, it's an ordering of n objects. Okay? In a permutation, order is important. Order matters. Okay? And you'll better understand this once we do a few examples of it. And then we're going to learn something called a factorial today. And factorial is represented by a symbol. It looks like this. We're represented by this symbol. And you might think, well, that's an exclamation point. Well, in English, it is an exclamation point. But in math, it's called a factorial. Okay? So we read this as, well, let me do something else. We read this, if I put an n in front of it, we read it as n factorial. Oops, factorial. And it is defined as, so if we have n factorial, what you do is you take whatever number n is, and you're going to multiply that by 1 less than n. So I don't know what n is, take away 1. Then we're going to multiply that by, take away 2 from n. We're going to multiply that by, we're going to follow this pattern. We're going to keep going until we multiply by 3, then we multiply by 2, then we multiply by 1, and we stop. So factorial, you take whatever number it is, you keep subtracting 1 from it, and keep multiplying that number all the way down till you get to number 1. Example, if we had 5 factorial, we would take 5 times, you take away 1, so 4 times, you take away 2, 3 times 2 times 1. So 5 factorial, you multiply all that together, and I believe it's 120. One thing that's going to be important later in our notes, and I'm not going to take the time to explain it right now, that if you ever have 0 factorial, it's not going to make any sense to you, but the reason why, the answer to 0 factorial is 1. 1 factorial is also 1. Okay, so that might not make a whole lot of sense. We just need to know that for some of our notes today. All right, here's the fundamental counting principle. If we have 2 events, one event can occur m different ways and another event can occur n different ways. The number of ways that both events can occur is m times n. If we have 3 or more events, the fundamental counting principle can be extended. So we have 3 events. In each of these events can occur m different ways, and then the second event would be n different ways, and then the third event would be p different ways. To find how many different ways that all 3 events could occur, we would multiply m times n times p. So now let's put actual numbers with that so it makes sense. We're going to use the fundamental counting principle for pizza. You are buying a pizza. You have a choice of 3 crusts, 4 cheeses, 5 meat toppings, and 8 vegetable toppings. How many different pizzas with 1 crust, 1 cheese, 1 meat, and 1 vegetable can you choose? So we're going to use the fundamental counting principle to find the total number of pizzas. Multiply the number of crusts, so 3, multiply by the number of cheeses, 4, the number of meats, 5, and the number of vegetables, 8. So the fundamental counting principle says we are going to multiply 3 times 4 times 5 times 8. And when you type that in your calculator or you do it by hand, you're going to get 480. So if you go to this particular pizza place, you could have 480 different pizza combinations. So here is a question where I would like you to pause the video and see if you can answer it on your own, and then start the video back up and check your answer with mine. If the pizza crust was not a choice in example 1, so get rid of the pizza crust choice, how many different pizzas could be made? Pause the video. If the pizza crust was not a choice in example 1, then we would only have 4 cheeses, 5 meat toppings, and 8 vegetables to choose from. So we'll use the fundamental counting principle, multiply those together, and we get 160 different pizzas you could make. Using the counting principle with repetition. Telephone numbers. A town has a telephone number that all begin with 329, followed by 4 digits. How many different phone numbers are possible? A, if the numbers can be repeated, and B, if the numbers cannot be repeated. So for question A, let's see, how many digits could we use? The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can't use 10, but we could use 0. So there are 10 different options. So we're saying that there are 10 choices for each digit. We're going to use the fundamental counting principle to find the total number of phone numbers. So we have 4 different digits, and we have, like for the phone number, it would be 329, 1, 2, 3, 4 different options, or 4 different places to put these numbers, and order matters. So in the first one, we have 10 different numbers to choose from. We're going to multiply that by how many choices do we have in the second place. Well, since the numbers can be repeated, we still have 10. In the third place, we will have 10 digits. And then in the fourth place, we also have 10 digits that can go in there, because this number could be 5555. I could simplify that. That would be 10 to the fourth, which gives me 10,000. So 10,000 different phone numbers could come from 329 in any digits. Now, if we cannot repeat the digits, we still start with 10 choices. But that's only for the first number. If you cannot repeat the choices after you choose the first number, then you only have 9 remaining choices for the second digit. And after you use the first digit and the second digit, now you only have 8 new ones, new choices for the third digit, and then 7 choices for the fourth digit. So for this one, we'll use the fundamental counting principle, multiply 10 times 9 times 8 times 7, because the digits cannot be repeated, and type that in your calculator, you get 5,040. So that's how many different phone numbers would be if the numbers cannot be repeated. Example 3, find the number of permutations. Okay, 8 teams are competing in the baseball playoff. In how many different ways can baseball teams finish the competition? So for this, the 8 different teams, it matters who comes in first, second, third, and so on. So we've got 8 places, got 8 teams. Got 8 places. And for that first place, we have 8 teams that could possibly come in that first place. But once that first team is chosen, for second place, we only have 7 teams left, because the same team cannot happen. So this is basically telling me that we cannot repeat teams. Third place, we've got 6 teams left. And then for fourth, we've got 5 teams left. And then for, I'm just not going to, for third, second, what am I doing? For fifth, sixth, seventh, and 8th place, we've got how many teams left? 4 teams, then 3 teams, then 2 times, and then 2 teams, then 1 team. Together, this is the same thing as that 8 factorial that we were talking about on the front page. So on your calculator, you can type all this in, a lot of time symbols, easy to make a mistake, or I wanted to show you that we do have factorial on our calculator. You're going to have to type in the 8 first, and then you're going to go to math, which is right here, math, And then we're going to use this and we're going to go over to probability, which is what we're studying right now. Probability, and you will see choice 4, it's kind of hard to see on here, but on your calculator you can see a little bit better, is the exclamation point, the factorial. So I'm going to hit 4. And then it says 8 factorial, hit enter, and it tells me 4,320. I think I said that wrong. 40,320. That's how many different ways 8 baseball teams could finish the competition. Now, how many different ways can 3 of the teams finish first, second, and third? So we got first, second, we've got third. First place could be any of the 8 teams, but whatever team gets first cannot also get second. So we have to take one away. 7 teams left to get second. And then to get third, we have 6 teams left. We don't need to put any more teams in it because we're just asking how many ways can we get first, second, or third. So we're going to use our fundamental counting principle. We're going to multiply these 3 numbers together, and we get 336. All right, there is a formula for when we have permutations of n objects when we're only taking part of them at a time, when we're only taking a certain amount of them at a time. So if we have r objects taken out of a group of n distinct objects, then we can denote this by this symbol that has a big P, and then it's got a subscript n and a subscript r at the bottom and the front, and then the last. So the way that they write it to me is a little confusing because the n is actually what comes first. But I'm going to compare this to this last baseball question that we just did. So this last baseball question is saying we have 8 teams, but we're only choosing, we're only doing the permutation of 3 of those teams. We have 8 teams, and we're doing the permutation of 3. So 8 would be like the total amount, and then 3 would be how many you're actually finding the combinations of, or the different orders. Here in symbols, I'm going to go ahead and take this and use this example here, P, and then with the little 8 here and the little 3 there. This is telling you a formula that you'll always use if you have a permutation. So we want to do n factorial. So the n is the first number. We're going to do 8 factorial, and then we're going to divide that by 8 minus 3 factorial. So the r is the second number. Okay, now you can type this in your calculator, but sometimes the numbers get really, really big and your calculator won't do all the work for you. I want to show you some other ways of doing this by hand. For me, a lot of times it's easier to do it on the paper than it is to type all this in the calculator. So I'm going to show you this trick. 8 factorial is the same thing as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay? And then on the bottom, 8 minus 3 is 5 factorial, which is going to be 5 times 4 times 3 times 2 times 1. So when we talk about canceling, like we go back to Algebra 1, we talk about canceling. You're allowed to cancel if things are factors, if they are multiplied. And you'll notice that on top we have 5, 4, 3, 2, 1, and on the bottom we also have 5, 4, 3, 2, 1. So these will cancel. So what I can do as a shortcut is when I have 8 factorial, I can start writing the numbers out, 8 times 7 times 6 times, until I have the last number is that number on the other side of the fraction, 5 factorial. Now 5 factorial means 4, 3, 2, 1. 5 factorial on the bottom is also 5, 4, 3, 2, 1. So these are exactly the same, and I can stop and I can cancel them. So here's my shortcut. So all I'm typing in my calculator is 8 times 7 times 6. Which we just did on the other page, and we got 336. I'm just showing you a different way of doing it using an actual permutation formula. So here's a new question. You have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. How many different orders can you complete 4 of the assignments? So this is a permutation. You've got 6 total objects, but we're only going to do 4 of them. So we're going to write this as a permutation 6 choose 4. So we're going to use our formula. On top is going to be the first number 6 factorial, and on the bottom is going to be 6 minus 4 factorial. So on top I still have 6 factorial, and on the bottom I have 2 factorial. So you can type 6 factorial into your calculator really easily. You get 720. On the bottom, 2 times 1 is 2. And we divide those and you get 360. So you can complete the 4 assignments in 360 different orders. How many different 7 telephone numbers are possible if all the digits can be repeated? So if all the digits can be repeated, and then what is the probability of guessing somebody's number correctly? So if all the digits can be repeated, let's see, 7 different telephone numbers, they can be repeated. That means we're going to have first number, second number, third number, fourth, fifth, sixth, 7. We're going to have 10 to the 7th for the different phone numbers, which is 1 and 7 zeros. 10 million different phone numbers can be chosen from that. And then what's the probability of randomly guessing somebody's phone number? Well, it's going to be 1 out of 10 million. Of course, we add area codes, and that's going to be even crazier to try to guess somebody's phone number. All right, today we're not really doing probability, but I did want to connect what we're doing to probability a little bit. This will be added to probability eventually. In example 3A, how many different ways can the teams finish if there are only 6 teams competing in the playoffs? So that's going back to our baseball question. Our baseball question for 3A was 8 teams with 8 places. So we're just going to take this exact same question and make it 6 teams with 6 places. So if we have 6 teams with 6 places, then we will have 6 times 5 times 4 times 3 times 2 times 1, which is 6 factorial, excuse me, which is 720. You were left a list of 9 chores to complete. In how many orders can you complete 5 of the chores? So here it's telling you the order matters, so that means we have to use permutation. We have 9 to choose from, but you're only doing 5 of them. So we're going to write this as permutation 9 choose 5. Make that 9 look like a bitter 9. 9 choose 5. Okay. We're going to use our formula that says do 9 factorial over, parenthesis, 9 minus 5 factorial. So I've got 9 factorial over 4 factorial. You can use your calculator. I'm going to do it writing it out just because I know some people are going to want to go to those higher level classes, and we do this in higher level classes, but we do it with letters instead of numbers. So I think it's important to see it written out. So I've got 987 times 6 times 5 times, then I hit 4. And 4 is the same as 4 on the bottom. So I'm going to stop and put a factorial there. Then I'm going to copy that 4 factorial on the bottom. Those cancel out. So on my calculator, I'm just typing in 9 times 8 times 7 times 6 times 5. Or you typed this into your calculator, and you should get 15,120. Different ways you can complete 5 of the chores. Permutations with repetition. I've seen these kind of questions like, I don't know, like ACT or in math contests here and there. To me, this is kind of confusing the way that it's written. It's basically saying that we've got well, I'm gonna use it for, we only have these for like letters in a word. We'll see when we read this in a second. Well, let's read this first. Find the number of distinguishable permutations of the letters in the word even. So what this is saying is we're going to reorder these letters. How many different orders can we write the word even? The problem is you cannot tell between the E and the E. So if I write my first E here, or if I switch that around and I write my third digit, my second E, in the first place, these are exactly the same, so they would only count as one way. They wouldn't be different ways. So when we have a situation where you're trying to find how many different things occur, but we've got repeats in there, what you have to do is you have to put like the number of different objects on top, and we're going to do that with a factorial, and then every single time something repeats, you're going to use a different factorial. So you would do number of repetition factorial multiplied by, if we have something else that repeats, number of different repetition factorial, and so on. That's what this is all saying right here. So let's see an example. So with even, the word even has 4 total letters. But in that word, the letter E is repeated 2 times. So what we do is we say on top, the permutation is going to be 4 factorial, but we're going to divide that by the E repeating 2 times. So we're going to do 2 factorial. So 4 factorial is 24. And then 2 factorial is 2 times 1, so 2. So we get 12 different ways we can reorder the letters in the word even. Now, if we take a bigger word, California. California has 10 letters. And we look carefully. California has a repeat of A, but it also has a repeat of I. Both of them occur twice, so each are repeated 2 times. Excuse me. So what we're going to do is we're going to have 10 factorial, the number of letters on top. Then on the bottom, we've got those 2 A's repeating and the, I was going to write an I, and the 2 I's repeating. So we do 2 factorial for the A's and 2 factorial for the I's. So if I'm going to write this out, you can type this in your calculator, no problem at all. And in fact, if you plan on type this in your calculator, make sure you know how to type it in, that it gives you the exact same answer as me writing it out. If all you're doing is writing the answers down, you may not realize if you're going to type it in your calculator wrong or not. Okay, 2 factorial is 2 times 1, so I'm just going to multiply that together and get 2, and then the other 2 factorial is going to be 2. So it looks like if I'm going to do this with canceling, I could cancel 2 times 2, which is 4, with the 4. So basically on top, I'm multiplying everything together except for 4, and cancel that with the 2 at the bottom. Type that in your calculator. However you typed it in your calculator, you should get 907,200. And I'm not really leaving you a lot of time to go type this in your calculator. But you can pause the video at any time. You can pause it right now, type it in your calculator, make sure you get the right answer. Or go type this in your calculator and make sure you get the right answer. So find the number of distinguishable permutations for the letters in the word tomorrow and in the word yesterday. Pause the video and try these on your own. Then unpause it and check with my answers. Pause the video now. Okay, the word tomorrow has 8 letters, and then we look here, there's 3 O's, so I'm going to do 3 factorial, and then we also have 2 R's, so I'll have a 2 factorial in the bottom, and they're multiplied together. So we've got 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Actually, let me just stop that at 3 factorial. And then we'll do 3 factorial, and then we're going to multiply that by 2 factorial, which is just the number 2. So those will cancel. I will cancel 2 factorial with, 2 with a 4 and get a 2 left over. I'm going to multiply 8 times 7 times 6 times 5 times 2. and I get 3360. Yesterday, 9 total letters. We've got the Y repeating twice, and we've got the E repeating twice. So 2 factorial times 2 factorial is 2 times 2. I've got 9 factorial divided by 4. Probably just type that into my calculator rather than trying to cancel stuff out for this one. And I get 90,720. All right, almost done. So we've got 2 scenarios. Let's say Ms. Criswell is offering her geometry class a contest to see who can come up with the most creative combination question. She's deciding between 2 different sets of prizes. Set A, if the prizes are first place gets a car, second place gets a new phone, and third place gets extra credit. And then our set B, if the prizes are awarded to the top 3 students and they all get extra credit. So besides the fact that this one has like way more expensive prizes, but really, I mean, extra credit is priceless, right? Besides that difference, what also is different about the scenarios? You were to put yourself in this class. There's 20 students in this class. If you were to put yourself in this class, what would be the difference about you winning one of these or the difference between you winning one of these? In example A, it matters which person gets first, second, and third. In example A, order matters. Because if your friend gets first place and you get third place, those might not be the exact same prize. And if you get first place and your friend gets third, again, that's a different order. So order matters for these. But for scenario B, top 3, if you're the first person picked and your friend is the third person picked, you all get the exact same prize. So the order is not important for example B. So today, when you're doing your assignment, you're going to have to figure out, does order matter or does order not matter? Because if order matters, we're using permutations. If order doesn't matter, that's what we're about to learn, the new thing. For scenario A, how many ways can she give away the prizes? For scenario A, if we're talking about a permutation, then we've got 20 students to pick from, and we're just doing 3, and the order matters. So we'd have 20 factorial over 20 minus 3 factorial. So I have 20 factorial over 17 factorial. So I am going to multiply this out by hand because I'm not typing it in, but I don't know if your calculator can handle 20 factorial. 20 times 19 times 18 times 17 factorial divided by 17 factorial. These cancel. We get 20 times 19 times 18. And there are 6,840 different ways to order the first, second, and third places. Now, scenario B, we're about to learn. Scenario B, where the order doesn't matter, it's going to be called a combination. So we're going to come back to that. We're going to come back to that in just a moment. And oh yeah, let me just come back to that. Okay. So combination. A selection of R objects from a group of N objects when the order is not important. When the order is not important. So to do combinations, we still have a formula that looks a lot like the permutations. We have a big C, we have a little n, and we have a little r. But the formula itself is a teeny tiny bit different. On top we still have n factorial. On the bottom we still have n minus r factorial. But then you also have to divide by r factorial. So I'm going to go up here and we're going to set this question B up. So we have 20 people in the class and we're choosing 3 of them. But since order doesn't matter, we're going to use this combination formula. We're going to do 20 factorial. We're going to do that over 20 minus 3 factorial. And then we're going to multiply the denominator by 3 factorial. So we're going to have basically the same thing we had right up here. We're going to have 20 factorial over 17 factorial, but then we have times 3 factorial down there. So this 20 over 17 factorial was this answer right here. But we still have the 3 factorial on the bottom. So I've got 6840 divided by 6. And we get 1140. So the different orders that we could have for scenario B, because order is not important, we have way less. We're picking the exact same people, but because the order is not important, we just have way less options. So books, you are picking 7 books from a stack of 32. If the order of the books you choose is not important, how many different 7 book groups are possible? So the number of ways you can choose 7 books from 32 is going to be 32, choose 7. So we do 32 on top, we do 32 minus 7 factorial, and then we multiply that by 7 factorial. Okay, I'm going to expand this a little bit. 32 factorial over 25 factorial times 7 factorial. Sorry, that doesn't look like a 7. There we go. Now, again, you can try this on your calculator. I'm going to expand it so you've seen it both ways. 29, 28, 27, 26, 25 factorial. And then on bottom we have 25 factorial, and I'm going to expand out the 7. 7 times 6 times 5 times 4 times 3 times 2 times 1. You don't really have to write times 1. The 25 factorials will cancel out. Now before I just type all this in my calculator, I like to see if there's anything else that I could cancel out. For example, if I multiplied 7 times 4, that's 28. So I could cancel out the 28 with the 7 and the 4. If I multiplied 6 and 5, that's 30, so that cancels with the 30. 3 times 2 is 6, and none of these are divisible by 6, but maybe I'll just look right here, and 2 divides out of 26, left with 13, and 3 divides out of 27, left with 9. So really what I will type into my calculator now is I have canceled out everything in the bottom. I'm going to be typing in my calculator 32 times 31 times 29 times 9 times 13. Type that in your calculator to get 3,365,856 different ways you could pick 7 out of 32 books. Movie rentals. Sorry, there we go. The local movie rental store. Ooh. Yeah, so this question is from like forever ago. Is having a special on new releases. The new releases consist of 12 comedies, 8 action, 7 drama, 5 suspense, and 5 family movies. You know what, I totally changed this question, and then I forgot to actually change it on the part that I had typed out. Oh well, so back in the day we used to actually go into a store to rent a movie. It was crazy. You think of this as being maybe like Redbox. There we go. This is like Redbox. All right. You want exactly 2 comedies and 3 family movies. How many different movie combinations can you rent? So this is how you're going to do this one. If you can choose 2 out of 12 comedies and 3 out of 9 movies, we're going to have 2 sets of combinations. And then we're going to use our fundamental counting principle to multiply those together. So 12 comedies, choose 2, is 12. And then right here we do 12 minus 2, which is 10 factorial. And then we do 2 factorial here. And then the other one, we're going to do 9 factorial, and we're going to choose 3. So in this space, we're going to do 9 minus 3, which is 6 factorial. And in this space here, we do 3. Now I'm going to simplify those by expanding them out. Let's see, this one's going to be 12 times 11 times 10 factorial over 10 factorial times 2. So those will cancel. And then the 2 can cancel with the 12 and make it a 6. And we get 66. Same thing for this one. We're going to do 9 times 8 times 7 times 6 factorial. And then on the bottom, I've got my 6 factorial. And over here, I've got 3 times 2 times 1. So the 6 factorials are going to cancel. The 3 can cancel with 9 and leave you with a 3. The 2 can cancel with 8 and leave you with a 4. So we've got 3 times 4 times 7 left over. 3 times 4 times 7 is 84. So we just type in 66 times 84 into our calculator, and 5,544 different combinations of movies that you could rent. So this is using that same information. You can afford at most 2 movies. How many movie combinations can you rent? So at most 2 movies means you don't have to rent 2. You could rent 0, or you could rent 1, or you could rent 2 movies. And how many different movies possible are there? We have to add up. Let's see. We had, sorry, I have to look back. We had 12 plus 8 plus 7 plus 5 plus 9. We add all of those up, and there's 41 total movies to choose from. You could rent 0, 1, or 2. So those are 3 different scenarios, 3 different combinations. So what you're going to do, excuse me, what you're going to do is you're going to do, I'm going to put it up here. You're going to do the combination of 41 movies, choose 0. You're also going to find the combination of 41 movies, choose 1. And then finally, you're going to do the combination of 41 movies, choose 2. Now, these are not all going to the same event. These are kind of like 3 completely separate events. So we're going to actually add these totals when we're done. All right, so 41, choose 0. That's going to be 41 factorial over, and then we do 41 minus 0 factorial times 0 factorial. So when we first started these notes and I started talking about factorial, I said you're going to need to know what 0 factorial is. And I told you the answer was 0 factorial equals 1. So we can just look at that as being 1. The second one is going to be 41 factorial divided by 41 minus 1 factorial times 1 factorial. And then the third one is going to be 41 factorial over 41 minus 2 factorial times 2 factorial. So I'm going to expand these out. 41 factorial over 40 minus 0 is 41 factorial. Well, if I do that, there's only one combination in which there are 41 movies and I choose none of them. There's only one way I can do that. Literally choose none. And then 41, choose one movie. If we have 41, and we do 41 minus 1, that's 40 factorial, and we multiply that by 1 factorial. So I'm going to have 41 times 40, and I'm going to expand it, but I can just stop right there at 40 factorial because on the bottom I have 40 factorial, and that 1 factorial is just 1. So if I have 41 different movies and I'm choosing just one of them, there are 41 different ways I could do that. Literally pick one of those 41. There are 41 different ways. And then the last one, 41 different movies to choose from, but we're going to choose 2 of them. So 41 factorial, and then 41 minus 2 is 39 factorial times 2 factorial. So we get 41 times 40 times 39 factorial over 39 factorial times 2 factorial. So those cancel. I get 41 times 40 over 2, and I'm going to go ahead and cancel the 2 with the 40 and get 20. So really I have 41 times 20, which is on my other piece of paper. Oh, 820. So if I take, I kind of ran out of space here. This is really supposed to say C combination 41, choose 0, plus combination of 41, choose 1, plus combination 41, choose 2. Then we get 1 plus 41 plus 820, which tells us there are 862 different ways that you could rent a movie or movies if you rent at most 2 movies. All right, and then this would be a very good time to pause the video. Try to figure out the number of possible movie combinations if you can choose 2 action movies and 2 dramas. After that, play the video and check your answer. Go ahead and pause it now. So if we're going to choose 2 action movies, there's 8 total action movies. So we're going to have a combination of 8, choose 2. And then we have a combination of, there's 7 dramas, choose 2. And the reason why I'm multiplying these is because you're finding the possible combinations of if you're choosing these and choosing those. Above we were adding because you weren't doing 0 movies and 1 movie and 2 movies. You were doing or. So we had to kind of look at them separately. But since you're doing and, you're putting them together, we will multiply these together. That is the fundamental counting principle when you're doing and, putting it together. So 8 choose 2. So we're going to have 8 factorial over, we do 8 minus 2 factorial times 2 factorial. Just 8 factorial over 6 factorial times 2 factorial. Here we've got 7 factorial over 7 minus 2 factorial times 2 factorial, which is 7 factorial over 5 factorial times 2 factorial. I'll write this out. So 8 factorial, I have 8 times 7 times 6 factorial over 6 factorial times by 2. Those cancel. The 2 cancels with the 8. And we get 28. 7 times 6 times 5 factorial over 5 factorial times 2. The 5 factorials cancel. The 2 can cancel with the 6. And we get 21. Multiply that together, and you should get 588 different combinations of 2 actions and 2 dramas. So your assignment's going to be a worksheet. It's going to be all word problems, just like these, for the most part, yeah. And you're going to have to first decide if you're going to use permutations, where order is important, or combinations where order doesn't matter. Make sure you download that worksheet and submit. I believe it's due in 2 days. I just wanted to one more thing put on this video real fast. A lot of you are having trouble with getting all of your pictures into one file, and I've been saying let's download this app, Adobe Scan. If you use Adobe Scan, I want to show you, it's really, really, really easy to use. I'll just use my, let me zoom out here, use my notes that I just did with you, and I zoom out, you know, and I take a picture with it. You see I took a picture, and then it says, you know, do you want to drag the corners to crop it, and then I'll go ahead and I'll just continue, and then I'm just going to take another picture real fast here, and then I'll continue, and let's say that, okay, so I'm done, it's only 2 pages, and I click on that, and oh no, it turned it, so I could rotate it. I'm sorry, I'm not really on the screen. I could rotate it, you know, make sure that it looks like a paper that you are sending into your teacher. We could crop it. You could clean some stuff up. It looks like I could, you know, erase whatever I had in that top corner. I don't even know what that was. You could fill selected with color. That looks good. I could go over to my second page. Looks like I need to rotate that one too. I don't know if my finger or something, maybe it was the camera was in the way here. Anyway, so I could clean that up if I want. There we go. And then when I'm done, I'm going to save this as a PDF. Do I? And let me click on it here, and there's my 2 pages right in one file, and it looks very good. Like, it doesn't look like a blurry picture, which you totally would expect it to look like if you're just taking pictures on your phone. Looks really good. Then all you have to do is hit share, and you can email the link to your school email address. I wonder if you can share it to your drive. Yep, there you go. You could share it to your drive if you have your school drive on your phone. I just wanted to show you this since we are going to be out for the rest of the year. You're going to have to learn how to do this. Okay? If you guys have questions about it, just contact me. I want to just make sure that everything you're handing in I can read, and those of you that don't like doing it on the computer, you like doing it on paper, or you don't have a stylus, although you need to buy one, get on Amazon. If you can't do it, then this is a really good way to scan your stuff in. All right, make sure you get on that worksheet. See me in office hours if you have questions. Talk to you soon.